So we have probability. Probability is simply the measure of how likely something is to happen. In other words, it tells us the chance of an effect occurring. You already know the normal English meaning of probability. It means how possible something is. The same meaning is applicable in mathematics. Probability have the same meaning in mathematics, but we express probability as number in mathematics. The probability of any event, probability of something happening is always between a 0 and 1. If the probability of something happening is a 0, it means that thing will not happen. If it is 1, it means the thing will surely happen, the effect will surely happen. But if it is between a 0 and 1, if it is greater than a 0 but less than 1, it means it may happen or may not happen. The probability is always between a 0 and 1. Once it is a 0, the event will not happen. That is no more a probability. You are sure that it won't happen. And if it is 1, it is no more a probability. It's very sure that the event will happen. The probability is always between a 0 and 1. So probability helps us to measure how sure or unsure something will happen. Now, mathematically, probability is being expressed as number of favorable outcome divided by number of possible outcome. Of course, every event, every experiment will have the possible outcome in them. Take for example, we want to determine if rain will fall or rain will not fall in a particular geographical location. Let's say we want to determine if rain will fall or rain will not fall in Malete. Now, for that event, for that experiment, our possible outcome is rainfall and no rainfall. Those are the two possible things we can get from that experiment. Is either we are able to predict that rain will fall or or rain will not fall. So our possible outcome here is rainfall, no rainfall. So the number of possible outcome is 1, 2. So what we have in possible outcome is just 2. So the total number of possible outcome is 2. So this um denominator will be 2. Now we have favorable outcome as well. Favorable outcome is the what we want to find its probability. That is our favorable outcome. Let's say we want to find the probability of rainfall. We want to find the probability of rainfall in Malete. So the first thing you need to do is to determine number of possible outcome. So the experiment is we want to determine if rain will fall in Malete. So the number of possible outcome is 2, either rainfall or rain did not fall. Now you have to determine number of favorable outcome. In this case, our favorable outcome is rainfall. We are dealing with rainfall. So you check your possible outcome. How many times did our favorable outcome appears rather? How many times did rainfall appear from our possible outcome? So this is our possible outcome. So rainfall only appear once. So number of favorable outcome will be 1. Then the probability of rainfall will be 1 all over 2. 1 all over 2. So this 2 is our total number of possible outcome, which is either rainfall or no rainfall. And this one is our total number of favorable outcome, 1 over 2. Now if you want to find the probability of no rainfall, probability that rain won't fall as well, so you determine the number of possible outcome. It is 2 as well. So in this case, our favorable outcome will be no rainfall. So no rainfall appear 1. So the probability of no rainfall will be 1 all over 2 as well. So that is the basic approach to finding the probability that an event will occur or an event won't occur. Now we have basic element of probability as well. We have experiment. An experiment is and activities that can produce one or more possible outcome. Generally, experiment is the situation under study, something that we want to consider its probability is what we call an experiment. So an experiment is any activities that can produce one or more possible outcome. Take for example, testing a blood sample to detect the presence of specific protein maker. This is an example of an experiment. We want to test if there is presence of protein in a blood sample. So our outcome is either we detect protein or we did not detect protein. So we have outcome. So since these activities will give us an outcome, then it is an experiment. And if you want to determine whether rain will fall and rain won't fall, we will have outcome too. So the outcome is an experiment as well. The experiment is any activities that can produce one or more possible outcome. Then we have trial too. And this is each individual performance of an experiment. It refers to the number of time we perform an experiment. So trial is number of time we perform an experiment. For example, if we test 10 blood samples one after if we test 10 blood sample one after another, then each test is a trial. The first test is a trial, the second test is a trial as well. So each individual experiment, each individual test is what we called trial. Take for example as well, we want to determine if rain will fall and rain will not fall. So the first time we conduct the experiment, we check if rain will fall, that is first trial. The second time we check if rain will not fall, that is second trial. Now we have outcome too. Outcome is result of one trial. I already explained that for this experiment the outcome is protein detected or protein not detected. If you want to determine whether rain will fall or rain won't fall in Malete, the outcome is rainfall and no rainfall. So outcome is the result of one trial. Now we have sample space as well. Sample space is set of all possible outcome of an experiment. The set of all possible outcome of an experiment. Sample space is just a way of representing all possible outcome of an experiment. Take for example, we want to we want to conduct an experiment, and the purpose of the experiment is to check if rain will fall in Malete or rain won't fall. So the sample space for that experiment, sample space is represented with S, then is equal to, you open a bracket, then you write each outcome, separate them with a comma. So for the experiment that rain will fall in Malete, the outcome is rainfall or no rainfall. So if you want to represent that as sample space, it will be rainfall. This is rainfall, then comma, no rainfall. So this is how you write sample space. Another example is for this one. For this experiment, we want to test the presence of a specific protein in a blood sample. So the outcome is either that protein is present or that protein is not present. So the sample space will be S is equal to, open bracket, okay, I already have it here. S is equal to, open bracket, the first outcome, protein detected, comma, protein not detected. Then we have sample point as well. Sample point is a single possible outcome in the sample space, e.g. protein detected. Now for this sample space, each outcome is what we refer to as sample point. So each outcome in a sample space is what we call sample point. So this is a sample point, this is a sample point, this is a sample point, and this is, so each outcome in a sample space is called sample point. Now we have this as example one. The question says we should write down the sample space for rolling a single die. So if you roll a die, then we should find the sample space. Now a die has six side. So when you roll a die, it's either the first side show, the second one, the third one, the fourth one, fifth one, and sixth side. So for a single rolling of die, the sample space will be S is equal to 1, 2, 3, 4, 5, 6. So this is the sample space for rolling a single die. Is how you get the face that have 1, the face that have 2, the one that have 3, 4, 5, or 6. So each of these guy they are sample point. So this one is an outcome, this is an outcome, this is an outcome, an outcome, outcome, and an outcome as well. Each of them they are sample point. I have another example. This is example 2. So the question says in a bag of 3 red, 2 blue, and 1 green ball, what is the total number of possible outcomes? So when you have a question like this, just add everything together. That will be the total number of possible outcome. So the total number of possible outcome here is 2 plus 3, or 3 plus 2, that is 5, plus 1, that is 6. The total number of possible outcome here is 6. For this example, the total number of possible outcome here is 6 as well. This will be 1, 2, 3, 4, 5, 6. The total number of possible outcome here is 6 as well. Don't forget that each sample point are outcome. Now, we have some common experiment in mathematics and their sample space and the number of outcomes. So I summarize them here. So in mathematics, in these topics, these are the experiments you will be dealing with the most. Of course, we will do some applications as well, but for pure mathematics, these are the experiments you will come across the most. The first one is tossing a coin once. Now, if you toss a coin once, you either obtain a head or tail. So the sample space for this is head or tail. So the number of outcome is 2. And if you toss it twice, then this will be the sample space and the number of outcome will be 4. If you roll a die once, then this will be the sample space, the number of outcome is 6. If you roll a die twice, this will be the sample space, the number of outcomes is 36. Then we have the fifth one as well. So this is just a summary table to help your study. So if you can cram this, it is okay, but just please take note. So if you can remember all of this, if you want to solve any question in probability, it will be very easy to determine the total number of outcomes. So once you know the total number of outcomes, your problem is 60% solved. So let's move to different approach or types of probability. The first one we'll be discussing is called classical probability, also known as classical approach to probability. In classical probability, we find the probability of an event without performing an experiment. And before we can have probability, before we can check probability of an event, then we have to perform an experiment like I explained. But in classical probability, there is no need for performing an experiment. So we don't need to carry out a real life test or observation before we determine probability. Instead, in classical probability, we make use of already known fact or assumed data or existing information to find the probability of an event. Unlike empirical approach, here we perform an experiment and record the result. For empirical approach, there will be an experiment will be performed and the result will be recorded. But in classical approach, we use already known data. For example, when you roll a die, you already know the possible outcome, and the possible outcome is 1, 2, 3, 4, 5, 6. So you can find the probability of any event from the data that we have. Another example is if for a pregnant woman, is that the pregnant woman give birth to a boy or a girl? So we know the outcome already. So we can only find the probability of an event from that outcome. So there is no need of performing an experiment for classical probability. And probability has the same formula, just that the way we write it might be different. And the formula is, it is just one formula. The formula is number of favorable outcome divided by number of possible outcome. Here I represent the probability of an event with P of E. Then N of E is probability number of favorable outcome, and N of S is number of possible outcomes. So this is how we find probability, either for classical probability, the one that did not require experiment, or for empirical probability, the one that require experiment. We use the same formula. Now there are some important law or conditions you should know. The first one is zero is less than probability of an event less than or equal to probability of an event less than or equal to 1. The interpretation of this first condition is that the probability of an event is always between a 0 and 1, like and explain. So probability of an event cannot be 1 and it cannot be 0. If it is 1, then the effect will happen. If it is 0, the effect will not happen. So this is how we represent that statement mathematically. Then we have this probability of sample space is 1. Then we have the third one as well. When we start applying them, you will understand them. Now I have another example here, which is example 3. The question says a coin is tossed once. What is the probability of getting a head? A coin is tossed once. What is the probability of getting a head? Like I told you, whenever you have a question under probability, the first thing you need to do is to determine the number of possible outcomes. Determine your sample space. Now for this one, a coin is tossed once. And if you toss a coin once, then our sample space will be head or tail. Our sample space will be head or tail. So the total number of possible outcome is 2. We only have 2 outcome here, which is 1 and 2. So our n of s is equal to 2. So the question says we should find the probability of getting a head. So our favorable outcome is head. So you come to your sample space, you count the number of head that we have. We only have 1 head. So our n of E is equal to 1. So the probability of getting a head will be equal to n of E divided by n of S, and this will be 1 all over 2. So this is the probability of getting a head. Now I have another question. This one says a dial is rolled once. Find the probability of an even number. So you have to determine your sample space. Since it is a dial and the dial was rolled once, so our sample space will be 1, 2, 3, 4, 5, 6. So for a single roll of a die, remember I said this is what will be the sample space. So the question says we should find the probability of getting an even number. That is, if you roll this die once, what is the probability of getting an even number? So our possible outcome here, the number of possible outcome n of s is equal to 6. Now our n of E is what? So the question says we should find the probability of getting an even number. So you come to this sample space and you count the number of even number in this set of number. Now this will be even number start from 2. Any number that 2 can divide and there won't be any remainder is even number. So 2, 4, 6. So we have 1, 2, 3. So we have 3 favorable outcome in this sample space. So our number of favorable outcome will be 3. So the probability of getting an even number will be 3 over 6 and this will be 1 over 2. I have another question, example 5. A dial is rolled once. Find the probability of getting an even number. A is find the probability of getting an even number. B is find the probability of getting a number greater than 4. So for this A, we already solved that in the previous example. So the probability of an even number is 1 all over 2 since it is a single roll of a die. And B, the probability of getting a number greater than 4. So this is our sample space, remember, 1, 2, 3, 4, 5, 6. So you come to this sample space and you check the numbers that are greater than 4, 5 and 6. So they are 2. So the probability of getting a number greater than 4, probability of getting a number greater than 4, n greater than 4 will be 2 over 6 and this will be 1 over 3. So we have another example. The question says a bag contains 5 red, 3 blue and 2 green balls. Find the probability that it is. Sorry, this question is not correct. The correct question should be a bag contains 3 red, 3 blue and 2 green balls. If a ball is selected at random, find the probability that A, it is red. Now, the first thing we need to do is to determine our sample space so that we will know the total number of possible outcome. But this question is straightforward. The total number of possible outcome ns will be 5 plus 3 plus 2. So this will give us 10. Total number of possible outcome will be 10. Now for question A, you have to find the probability that the ball that is selected is a red ball. The probability that the ball is red will be equal to the same formula, number of favorable outcome over number of possible outcome. So we have 5 red ball here. Since we want to look for the probability of finding a red ball, so our favorable outcome will be 5. So the probability of getting a red ball, the probability that the ball selected is red ball will be 5 over 10 and this will be 1 over 2. Then for question B, you have to find the probability that it is not green. Now, from this important condition that I explained this first one. Now this second one, probability of sample space is equal to 1. The meaning is that if you add each sample point together, then they will give you 1. The probability of each sample point together is equal to 1. And this example, this one, a single when we toss a coin once, you know the sample space is h comma t, h and t. So the probability of getting h plus the probability of getting t is equal to 1. This is the interpretation of this second condition. Now for this question, we have to find the probability of not getting a red. Now for this event, now this question A is a single event. Inside one experiment, we might have different effects. Now for this question A, this is one event. The event is to determine if the ball is red. You close that chapter. For this second question, that is another event inside one experiment. So inside one experiment we might have different event. So each event in an experiment will have its own sample space, but the sample space of that experiment is the most important. So for this experiment these are the sample space of this experiment, and this one we have, this is one effect. We have to determine if it is red. So this is an effect, so it can either be red or not red. So this one will have its own sample space too. The sample space will be red, not red. For this one, the sample space will be green, not green. So each event in an experiment will have their own sample space, but the sample space of the whole experiment is the most important. So you ignore the sample space of this event and the sample space of this event. Not that you ignore them totally, you can also apply them to compute their probability. Now from the law I told you, the probability of S is equal to 1. The interpretation of this is that the probability of sample space in an effect, the probability of sample space in an effect is equal to 1. That is, when you add the probability of all sample point in an effect together, then our answer will be 1. Now for this question B, our sample space is green or not green. So probability of green plus probability of not green so for this question B, probability of green plus probability of not green will be equal to 1. Probability of green plus probability of not green will be equal to 1. So we are interested in finding the probability of not green. So the probability of not green will be equal to 1 minus probability of green. So how do we find the probability of green? The probability of green will be 2 over 10. Probability of green will be 2 over 10. Now we can compute the probability of green directly from the experiment, but we cannot compute the probability of not green directly from the experiment. That is why we are using the sample space for the green effect. So the probability of green from the entire experiment is 1 all over 5. So probability of not green will be 1 minus 1 all over 5, and this will give us 4 over 5. So another example, the question says a letter is chosen at random from the word probability. Find the probability that the letter chosen is a vowel. So if we pick a letter from this word, then we have to check if the letter chosen or the letter we picked is a vowel. So the first thing you do is you find the number of possible outcomes. So if we pick a number, if we pick a letter randomly, so the letter can either be P, R, O, B, A, B, any letter of this word. So each of them is our possible outcome. So there are 11 letters here. So the number of possible outcome is 11. So the question says we should check if the number is vowel, or if the number is vowel, we have to count the number of vowel letters in this word. I think the vowel we have in English is O. The vowel we have in English is O, A, O, I, U. So the number of vowel we have in English is A-O-I-U. So we have to check for A in this letter. Okay, we have A there. How many times? One. We don't have any again. We have O. How many times? One times. We have I. How many times? I is two times. So this is one, two, three, four. Did we have U? We don't have U. So the number of vowel we have here is A is 4, which is A, O, then I two times. So our favorable outcome is 4. So our N, E is 4. So the probability of vowel is 4/11. We have another example. A bag contain 2 red ball, 3 blue ball and 3 green ball. Find the probability if a ball is chosen at random. Find the probability that it is not blue. So the total number of possible outcome here will be 2 plus 3, which is 2 plus 3 plus 2, which is 7. So we have, if a ball is not picked at random, we have to find the probability that the ball picked is not blue. So remember I said we cannot compute the probability that the ball is not blue from the data of this whole experiment. But remember I said there is an event in each experiment. So this one is an event. We want to determine whether the ball is blue. The ball is not blue. So for this event, the ball can either be blue or not blue. So the probability that the ball is blue plus the probability that the ball is not blue is equal to 1. So the probability that the ball is blue will be 3/7. Probability that the ball is blue will be 3/7. So the probability that the ball is not blue is 1 minus the probability that the ball is blue. So this will be 1 minus 3/7, and this will give us 4/7. So we have the last example. The question says a die is rolled once. Find the probability of getting a multiple of 27. A die is rolled once. Find the probability of getting a multiple of 27. So the sample space is 1, 2, 3, 4, 5, 6. So we have to find our N of S is 6. So our N of E will be what? So we have to count the multiple of 27 in this sample space. Now what multiple of 27 means is that any number that if 27 divide that number, there won't be any remainder. So did we have any number here that 27 can divide without any remainder? No. All number in this sample space, if 27 divide them, we have remainder. So number of favorable outcome is 0. Therefore the probability of having a multiple of 27 will be 0 as well. Let's say the question asks us to find the probability of finding multiple of 3 instead of 27. So we have our normal sample space. Now multiple of 3 means any number that 3 can divide without remainder. So from this 3 can divide 3 without remainder, then 6 as well. So our favorable outcome will be 2. So it's only 2 number that are multiple of 3. So the probability of multiple of 3 will be 2/6, which is 1/3.